If Z is equal to R1 cis alpha and W is equal to R2 cis beta, then when you multiply, ZW is R1 R2 cis alpha plus beta. In other words, it's much easier to multiply when we're in polar form. When we multiply two complex numbers, we multiply the moduli, that's the R1 R2 part, and add the arguments, that's the alpha plus beta, adding or subtracting multiples of 2 pi to ensure that we stay within the domain of the principal argument from negative pi to pi. Also, Z divided by W is R1 divided by R2 cis alpha minus beta. When we divide two complex numbers, we divide the moduli and subtract the arguments, again adding or subtracting multiples of 2 pi to ensure that the argument stays between negative pi and pi. Now what I'm going to do here at the end of the video is prove this one. So you can either watch that or not, it's up to you. Okay, so Z is R1 cis alpha, W is R2 cis beta, and that means that Z is R1 cos alpha plus I sine alpha, and W is equal to R2 cos beta plus I sine beta. So ZW would be equal to R1 cos alpha plus I sine alpha multiplied by R2 cos beta plus I sine beta. And that is going to be R1 R2, and then we'll have cos alpha plus I sine alpha multiplied by cos beta plus I sine beta. So that's R1 R2, and then expanding out we've got cos alpha cos beta, and then if we do this part here, that would give us plus I squared sine alpha sine beta. I squared is -1, so that's minus sine alpha sine beta, and then doing the cross terms, which is this one and this one, we would get I into which way we're on, should I do it? Sine alpha cos beta plus cos alpha sine beta. Now, from work that you did in year 11, you should be able to recognize that as being the cosine of alpha plus beta. And you should be able to recognize that as being the sine of alpha plus beta. And so we've done it. We've got R1, R2, and then we've got cos alpha plus beta plus I sine alpha plus beta, which is R1, R2 cis alpha plus beta.